Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to be covering the process of dividing two polynomials through a process called polynomial long division. So before we get into polynomial long division, we need to first recap how to do regular long division, because the process for doing regular long division with regular numbers, is going to be the exact same as the process for dividing two polynomials using long division. So what we're going to do is we're going to do 48 divided by 4 the long way using long division. Now I know that you know that 48 divided by 4 is 12. We're not focusing so much on the numbers as in the process. So we're going to go through the long division process, and I want you to pay more attention to the process and the steps and the algorithm than the actual numbers. So there are two parts of a division problem. We have the dividend and the divisor, and the divisor is what you're dividing by. So the dividend 48 is going to go in the division box, and then the divisor 4 is going to go outside. Now we're not going to worry about decimal points here because we're not going to need those for polynomial long division. So what you do is you compare the divisor to the first digit in the dividend. And what you're going to ask yourself is, how many times does 4 go into 4? Another way of asking that is, what can you multiply 4 by to turn it into 4? So that's just an alternative way of asking that. So what can you multiply 4 by to turn it into 4? Well, you multiply it by 1. So what you do is you put the 1 over this 4 here, and then you're going to multiply. So then you're going to multiply this 1 by the divisor 4. So 1 times 4 is 4. You're going to write it below here, and then you are going to subtract them. So 4 minus 4 is 0. Then you're going to bring down the next digit, 8. And then you're going to do that again. So you're going to compare the divisor 4 to this 8 down here, and you're going to ask yourself, what can you multiply 4 by to turn it into 8? Well, you multiply it by 2. So you write the 2 here above the 8. Then you're going to multiply this 2 by this 4. So 2 times 4 gives you 8. You're going to write it below here, and then you're going to subtract them. So this number down here is what is called the remainder. And this number up top here, this 12, is the quotient. So we did get a quotient of 12, like we should. Remember, quotient is the answer to a division problem. And since the remainder was 0, that means that 4 does go into 48. So 4 goes into 48 exactly 12 times with no remainder left over. So we're going to basically follow that same process when we divide two polynomials. So what we're going to start with is dividing a polynomial by a monomial using long division. So we're going to take a polynomial with multiple terms, and we're going to divide it by a single term. Now, here's the thing about polynomial long division, is that both polynomials that that you are dividing must be in standard form. If your polynomials also contain any missing powers, like your polynomial jumps from x cubed to x and you are missing an x squared, you must put a 0 in the appropriate spot as a placeholder. And that also includes any missing constants. And this step is going to be crucial, because you're going to notice as we go through our first couple of long division problems that like terms always go in the same column. So if any of your polynomials are ever missing any terms, you do need to put a 0 in the appropriate spot as that placeholder so that you make sure that like terms remain in the same column. When we actually do a couple of examples, you'll see what I mean by that. Then what you're going to do is you're going to compare the first term in the dividend to the first term in the divisor. In this case, there's only going to be one term in the divisor, but we're going to get into dividing a polynomial by a binomial. So you're going to compare first term to first term. And what you're going to ask yourself is, what do I need to multiply the first term in the divisor by to turn it into the first term of the dividend? The answer to that question is going to go in the quotient spot right above it. And you're going to need to make the coefficients match. So you'll have to ask, okay, what do I need to multiply this coefficient by to turn it into this? And you also need to ask, how many more powers on this variable do I need, if you need any? So if the powers already match, you don't have to worry about it. But if the power in the dividend is higher than the power in the divisor, you're going to ask, how many more powers of x do I need? And then you're going to go through the long division process, and you're going to keep comparing first term to first term as you go throughout the division. Now, here's how to write your answers. So when you were finished with the division and you were finished with the division when what is in the remainder spot no longer contains a variable. If you get a remainder of 0, then great. That means the polynomial you divided by went into the divisor. However, you might get a variable that's, you might get a remainder that is not 0. So you are finished with the division when the remainder no longer contains a variable. And if there is a remainder, you're going to write your answer as a mixed number. So you're going to write it in the format of quotient plus the remainder divided by the divisor. So what we're going to do is we're going to divide 2x squared plus 6x plus 12 by 2x. So the first part of the division problem is the dividend, second part is the divisor. So I'm going to put the dividend 2x squared plus 6x plus 12 in the division box, and 2x is going to go outside the division box. Now before we do anything, what we're going to need to check is that the polynomials are in standard form and that we have no missing powers. So if you look at the first polynomial, we have x squared, x to the power 1, and 12. So the highest power appears to be 2, the powers decrease with the constant on the end, and it doesn't look like we are missing any powers between the highest and the lowest. So that means that this first polynomial is in standard form and there are no missing powers, so it is all set to go inside the division box. Then we're going to put the divisor 2x outside the division box. And here's what we're going to do. We are going to compare the first term in the dividend to the first term in the divisor. So I'm actually going to switch colors here for this. So you're going to compare this first term here to this first term here. And what you're going to ask yourself is, what do I need to multiply 2x by to turn it into 2x squared? So let's first look at the coefficients, 2 and 2. They already match, so we don't need anything on the coefficients. But the divisor has an exponent of 1, and this has an exponent of 2. So how many more powers of x do you need to turn the x to the power 1 into x to the power 2? Well, you need one more power of x, so x to the power 1 is going to go in the quotient spot up here. So if you multiply 2x by x, you're going to get 2x squared. So after you figure that out, what you're going to do is you're going to multiply this x by this 2x. So x times 2x is 2x squared. You're going to write it below here. And then I want you to get in the habit of subtracting. So then you are going to put parentheses around these and subtract. The parentheses aren't going to be essential here, but I want you to get in the habit of putting parentheses around what you're subtracting, because when we do get to divisors with two terms, both terms are going to get subtracted. So just get in the habit, put parentheses around it, and subtract. Give me a second. So then what we're going to do is we're going to subtract them. 2x squared minus 2x squared is 0. Now this should happen. These two terms should cancel out to 0. If it doesn't, that means something is wrong in your quotient. Then after that subtraction, you're going to bring down the next term, and don't forget that the 6 is positive. So I'm going to bring 6x down here, and then I'm going to go through that process again. Give me a second. So what we're going to do is we are going to compare our divisor 2x to this term down here, 6x. And what you're going to ask yourself is, what do I need to multiply 2x by to turn it into 6x? Well, let's start with the coefficients. What do you need to multiply 2 by to turn it into 6? Well, you need to multiply it by 3, and since it's positive, I'm going to separate these with a plus sign. And then I have an x to the power 1 here and an x to the power 1 here. So I already have matching powers, so when the exponents on your variable match, you don't need any more powers of x, so all you would need to do is multiply it by 3. So then what I'm going to do is I'm going to now multiply this 3 by this 2x. So 3 times 2x is 6x. Put parentheses around it and subtract. So 6x minus 6x will give you 0, like it should. So 6x minus 6x is 0. And then we're going to bring down the next term. We're going to bring down that positive 12. Now, if you take a look at what's in the remainder spot now, this 12 has no variable. So this 12 right here is your remainder because you're not allowed to take away powers. You're going to be adding powers. So since there's no more variables on this, this right here is your remainder. So then the quotient is this x plus 3. So here's how you're going to write your answer. You're going to write your answer in a mixed number format in the form of quotient plus remainder divided by divisor. So you're going to write this as the quotient x plus 3 plus the remainder 12 divided by the divisor 2x. And then that is going to be your final answer. So that is going to be the basic gist of polynomial long division. So I want you guys to try this one out for yourselves. Now, one thing I will point out is you have to make sure that both polynomials are in standard form and that there are no missing terms. So if you look at the first polynomial, we have 6x cubed minus 3x squared plus 9x. So the powers do appear to be decreasing, listed from highest to lowest, and we're not missing any exponents, but what we are missing is a constant. So any missing constants do need a 0 as a placeholder, and that's actually going to be important when we get to the remainder. So we're going to just put a plus 0 on the end of this because this first polynomial was missing a constant. And then you're going to put the 3x outside the division box here. So I want you guys to pause the video and attempt this one yourselves, and then resume when you are done and ready to check your answers. All right, so we're going to compare the first term in the dividend to the first term in the divisor. So what do we need to multiply 3x by to turn it into 6x cubed? Well, let's first look at the coefficients. What do I need to multiply 3 by to turn it into 6? Well, you need to multiply it by 2. I have an x to the power 1 here and an x to the power 3 here. So how many more powers of x do I need? I need 2 more powers of x. So we're going to multiply it by 2x squared. So then we are going to multiply 2x squared by 3x. So 2x squared times 3x is going to be 6x cubed. Then you're going to write it below here, put parentheses around it, and subtract it. 6x cubed minus 6x cubed is 0. Then you're going to bring down the next term and take the minus sign with it because that 3 is negative. So we're going to bring down a minus 3x squared. And then we're going to compare first term to first term again. So we're going to compare 3x to negative 3x squared. And we're going to ask ourselves, what do I need to multiply 3x by to turn it into negative 3x squared? Well, let's start with the coefficients. What do you need to multiply 3 by to turn it into negative 3? Well, you need to multiply it by negative 1. And then I have an x to the power 1 here and an x to the power 2 here. So how many more powers of x do I need? I need 1 more power of x. So then I'm going to multiply negative x to the power 1 by 3x. So negative 1 times negative 3 is negative 3. X times x is x squared. Then put parentheses around it and subtract. And yes, we do have a double negative. So negative 3x squared minus negative 3x squared is 0. Then you're going to bring down the 9x, and then we're going to do some comparisons again. So now we're going to compare 3x to 9x, and we're going to ask ourselves, what do we need to multiply 3x by to turn it into 9x? Well, let's start with the coefficients. What do you multiply 3 by to turn it into 9? Well, you're going to multiply it by positive 3. And then I have an x to the power 1 here in the divisor and an x to the power 1 here. So since the powers of x already match, you don't need any more powers of x, so we're just going to multiply it by 3. So then we're going to multiply 3 by 3x. So 3 times 3x is 9x. 9x minus 9x is 0 and cancels out. And then you're going to bring down the plus 0, that constant that you added on the end. And you are done with the division when there are no more variables in your remainder spot. So the remainder is actually 0. When you do a division problem and you get a remainder of 0, that means that the 3x actually went into 6x cubed minus 3x squared plus 9x. So that means that 3x is a factor of 6x cubed minus 3x squared plus 9x. So if your remainder is 0, your quotient is just 2x squared minus x plus 3. You don't need to write it as a mixed number because 0 divided by anything is just 0. So when you don't have a remainder, you don't need to indicate a remainder. The remainder of 0 means that it went in evenly and that your quotient is it. So 2x squared minus x plus 3 is going to be your final answer. Now, if you are dividing a polynomial by a binomial, what's going to happen with this group is that we're going to be dividing a polynomial with multiple terms by another polynomial with exactly 2 terms. So instead of only having 1 term in the divisor position, we're going to have 2. So what you're going to do is you're going to compare the first term in the dividend to the first term in the divisor, And you're going to ask yourself, what do I need to multiply the first term in the divisor by to turn it into the first term of the dividend? Now, when you get to this step here with the multiplication, you're going to be multiplying to 2 terms in the divisor. So both terms in the divisor are going to get multiplied, so you must distribute. So when you are multiplying the divisor, don't forget to distribute. And another reason that I'm having you get in the habit of putting parentheses around this is not only because of the occasional double negative, but because when you're dividing by a binomial, you are going to be subtracting 2 different terms in this step. And both terms are going to get subtracted. So when you subtract, you need to not only use parentheses, but you also need to remember to distribute the minus sign to both terms that are getting subtracted. So this is an example of a polynomial divided by a binomial. So we have the polynomial x squared minus 5x plus 8, which does appear to be in standard form. And then we're dividing it by x minus 3, which is another polynomial that is in standard form. So what I'm going to do is I'm going to put x squared minus 5x plus 8 in the division box. And then I'm going to put x minus 3 outside the division box. So then what I'm going to do is I am going to compare the first term in the dividend to the first term in the divisor. Going to try and color coordinate this here. So we're going to compare this first term, this 1x to the power 1, to this 1x squared. And we're going to ask ourselves, what do we need to multiply x by to turn it into x squared? Well, the coefficients already match, so we don't have to worry about that. I have an x to the power 1 here in the divisor and an x to the power 2 here in the dividend. So how many more powers of x do I need? I need 1 more power of x. So I'm going to multiply it by x to the power 1, and I'm going to put that up here above in the quotient spot. Then, when I multiply, here's where you need to distribute. So we're going to multiply x by x minus 3, and because x minus 3 is a binomial with 2 terms, we're going to need to make sure that both terms get multiplied. So I'm going to have to distribute this x to this x minus 3. So x times x is going to give us x squared, and then x times negative 3 is going to give us negative 3x. Now, both of these terms are going to get subtracted, so I'm going to put parentheses around both of them and put the minus sign outside the parentheses because both terms are going to get subtracted. So then, x squared minus x squared is going to give us 0. That should happen. Those first terms should cancel out. That's an indicator that your quotient's right so far. Just be very careful though, this minus sign technically went to both of them. So a negative times a negative is a positive. So when you multiply this negative times that negative 3x, they turn into positives. So negative 5x plus 3x is going to give us negative 2x. So just be very careful with that with your double negatives. Both terms are getting subtracted, so you need to distribute that minus sign to both terms. Now, after this, what you're going to do is you're going to bring down the next term, and you're going to take the plus sign with it. So I'm going to bring down the plus 8. Immediately after subtracting, you should bring down the next term and then any sign to its left. So immediately after subtracting, bring down the next term. So then we're going to go through that again. We're going to compare the first term in the divisor by this first term down here this time. And what we're going to ask is, what do I need to multiply 1x by to turn it into negative 2x? So let's start with the coefficients. What do you need to multiply 1 by to turn it into negative 2? Well, you need to multiply it by negative 2. Then we have an x to the power 1 here and an x to the power 1 here. So since the powers on x already match, we don't need any more powers of x, so we're just going to multiply it by negative 2. When you do the multiplication step, because the divisor contains two terms, you need to make sure that you are distributing. So I'm going to distribute this negative 2 to the x minus 3. So negative 2 times x is going to give us negative 2x. And then negative 2 times negative 3 is positive 6. Then you're going to throw parentheses around both of these terms, and both of these terms are going to get subtracted. So then negative 2x minus negative 2x cancels out, because remember this minus sign went to both of them. And then 8 minus 6 is going to give you 2. You are done when what's in the remainder spot has no more variables. So since this has no more variables, this here is our remainder. So that means our quotient is x minus 2. So writing our answer in mixed number format, it's going to be the quotient x minus 2 plus the remainder 2 divided by the divisor x minus 3, and then that is going to be our final answer. So you guys are going to try this one for yourselves. I am going to kind of help you set it up. Now, just going back to this question really quick. You might notice that in every single vertical column, there are like terms. So the x squareds here were both like terms and they went in the same column. In this entire column here, we had x terms, and then in this entire column here, we had constants. So when you're doing the polynomial long division process, like terms should always be in the same column. So if either of your polynomials are missing any terms, you do need to add zeros as placeholders so that you can keep like terms in the same column. Remember, you cannot add or subtract unlike terms, so you need to make sure that you only have like terms in the same column. Now, if you are missing any powers and you forgot to put a 0 for a placeholder, you wouldn't get very far before you found that you had a column with unlike terms. So when you ever run into that, if you ever run into a situation where you're trying to add or subtract unlike terms, that means that you probably had a 0 that you didn't put as a placeholder where you should have. So you also can remember that you can also write all division problems as fractions. So this is just another division problem written in fractional format. And if you don't like it written in fractional form, what you can do is you can write it with the division notation if you wish. You can write this as 2x cubed plus 6x plus 2 divided by x plus 4. Also, excuse the lawnmower. I'm really hoping that's not going to be too loud. Now, if you look at the first polynomial, 2x cubed plus 6x plus 2. It does appear that the powers are decreasing. However, you might notice that there is no x to the power 2. We jump right from an x to the power 3 to an x to the power 1, and it just completely skipped over x squared. So you are missing a power here. You are missing an x squared term. Because you are missing an x squared term, you need to put a 0 as a placeholder where it should go. Now, the x squared term should go between the x cubed term and the x term. So when I'm writing the dividend in the division box, I'm going to put 2x cubed first, and then I'm going to put the 0x squared next. Then I'm going to put the 6x, and then I'm going to write the plus 2. So that's what I mean by you need a 0 as a placeholder. Since the x to the power 2 term was missing, you need to put a 0x squared between the x cubed term and the x term. Then we're going to divide it by x plus 4, which luckily is also in standard form. And now from here, now that I've got this set up for you guys, I want you guys to try the long division for yourselves. So I want you guys to go through this exact same process to divide these two polynomials. So go ahead and pause the video and then resume when you are done working and ready to check your answer. All right, so what we're going to do is we're going to compare the first term in the dividend, 2x cubed, to the first term in the divisor, 1x to the power 1. And we're going to ask ourselves, what do we need to multiply x by to turn it into 2x cubed? So let's start with the coefficients. What do you need to multiply 1 by to turn it into 2? Well, you need to multiply it by 2. Then I have an x to the power 1 here and an x to the power 3 here. So how many more powers of x do I need? I need 2 more powers of x. So this will be 2x to the power 2. Then what you're going to do is you are now going to multiply. So you're going to take 2x squared and you're going to multiply it by x plus 4. And because x plus 4 has two terms, don't forget to distribute. So 2x squared times x is going to give us 2x cubed. And then 2x squared times 4 is plus 8x squared. So then you're going to put parentheses around both of these and you are going to subtract. So this is where you need that 0 for a placeholder, because if you notice, 2x cubed, we have like terms in the same column. 0x squared and 8x squared, we now have like terms in the same column. If you didn't have that 0x squared there, you would have had 6x and 8x squared in the same column, which are unlike terms and cannot be subtracted. So yes, we now have like terms in the same column, so that means we're on the right track. Now remember, both of these terms are getting subtracted. So 2x cubed minus 2x cubed is 0. Then 0x squared minus 8x squared is going to give us negative 8x squared. Immediately after subtracting, you need to bring down the next term, and you're going to take the plus sign with it. So I'm immediately going to bring down the plus 6x, and then I'm going to go through that process again. So I'm going to multiply this first term down here, this negative 8x squared, by this first term up here, this x. And I'm going to ask myself, what do I need to multiply x by to turn it into negative 8x squared? So what do you multiply 1 by to turn it into negative 8? Well, you multiply it by negative 8. Then I have an x to the power 1 here and an x to the power 2 here. So how many more powers of x do I need? I need 1 more power of x. So then I'm going to multiply negative 8x by x plus 4, and then don't forget to distribute. So negative 8x times x is going to give us negative 8x squared. And then negative 8x times 4 is going to give us negative 32x. So then you're going to put parentheses around these and subtract both terms. Remember that both terms are getting subtracted. So then we're going to subtract one term at a time. So negative 8x squared minus negative 8x squared is 0. Then 6x minus negative 32x. Now remember, minus minus will turn into plus. So then this will turn into 6x plus 32x, which will give us 38x. Then immediately after subtracting, you are going to bring down the next term. So you're going to bring down the plus 2. So then we're going to do that one last time. We're going to compare the first term down here, this 38x, to this first term in the divisor x. And we're going to ask ourselves, what do I need to multiply x by to turn it into 38x? Well, what do I need to multiply 1 by to turn it into 38? I need to multiply it by 38, so I'm going to put a plus 38 up here. And then I have an x to the power 1 in my divisor and an x to the power 1 here. So the powers of x match, and we don't need any more powers of x. So then what we're going to do is we're going to distribute the 38 to the x plus 4. So 38 times x is going to give us 38x. And then 38 times 4 is going to give us positive 152. Then you're going to put parentheses around each of these and subtract them both. So then remember, the minus sign is going to get distributed to both terms. So 38x minus 38x is 0. Then 2 minus 152. So 2 minus 152 is going to give us negative 150. You are done when what's in the remainder spot no longer has a variable and there's no more terms to bring down. So since this no longer has a variable, this is our remainder. And that means this up here is our quotient. So writing our answer as a mixed number, we're going to write it as the quotient, which was 2x squared minus 8x plus 38, plus the remainder. Now adding a negative 150 is the same as subtracting 150, divided by the divisor x plus 4, and then that is going to be our final answer. So we're going to basically do the same thing here. Now keep in mind that when you are, but don't just blindly write your polynomials in the division box. You need to keep in mind that you need to make sure that both polynomials are in standard form, and you also need to make sure that you don't have any missing powers of x. So if you take a look at the dividend, which is the polynomial on top, we have 4x cubed plus 3x squared plus 4. You might notice that there is a missing power, x to the power 1. So there is a missing x term. So there is a missing x term right here between the 3x squared and the 4. So because you are missing a power of x, you need to make sure that you put a 0 as a placeholder. So 4x cubed is going to go first, then plus 3x squared. And because we are missing an x to the power 1, I'm going to put a plus 0x right here as a placeholder, and then I'm going to put the plus 4 after it. Then I'm going to divide it by x minus 3. I'm not going to keep switching colors because I'm afraid that if I keep doing that, I'm going to crash my computer, because that has happened in the past with too much color switching. So I apologize for that. This computer does not have good processing power. Anyway, so we're going to compare the first term in the dividend, 4x cubed, with the first term in the divisor, 1x. And we're going to ask ourselves, what do I need to multiply x by to turn it into 4x cubed? Well, what do I need to multiply 1 by to turn it into 4? I need to multiply it by 4. Then I have an x to the power 1 here and x to the power 3 here. How many more powers of x do I need? I need 2 more powers of x, so I'm going to be multiplying it by 4x squared. Then when you get to the multiplying step, don't forget to put parentheses around your divisor because you need to distribute. So 4x squared times x is going to give us 4x cubed. Then 4x squared times negative 3 is going to give us negative 12x squared. Then you're going to put parentheses around both of them and subtract both of them. And like terms are in the same column, so we're off to a good start. So then 4x cubed minus 4x cubed is 0. And then 3x squared minus negative 12x squared. Well, the minus will turn into a plus. So 3x squared plus 12x squared is going to give us 15x squared. And then yes, you do need to bring down the plus 0x because you need to make sure that like terms remain in the same column. So then we're going to compare the first term down here, this 15x squared, by the first term in the dividend, x. And you're going to ask yourself, what do I need to multiply x by to turn it into 15x squared? Well, what do I need to multiply 1 by to turn it into 15? I'm going to multiply it by positive 15. You need to separate them with something, so it's going to be plus 15. Then I have an x to the power 1 here and an x to the power 2 here. How many more powers of x do I need? I need 1 more power of x. So I'm going to multiply it by 15x to the power 1. And then don't forget, at this point, you need to distribute. So 15x times x is going to give us 15x squared. And then 15x times negative 3 is going to give us negative 45x. Now put parentheses around both of them, and you're going to subtract both of them. Don't forget that that minus sign needs to get distributed to both terms. So 15x squared minus 15x squared is 0. Then 0x minus negative 45x minus negative turns into positive, turns into addition. So 0x plus 45x will give us 45x. Then immediately after subtracting, you're going to bring down the next term. So I'm going to bring down the plus 4. And then I'm going to compare the first term down here, this 45x, with this first term up here, x. And I'm going to ask myself, what do I need to multiply 1x by to turn it into 45x? Well, all you need to multiply by is 45. And since the powers of x already match, you just need 45. So then at the multiplication step, don't forget to distribute. So 45 times x is going to give us 45x. And then 45 times negative 3 will give us negative 135. Then you're going to put parentheses around each of these and subtract. Don't forget that the minus sign is going to go to both terms. So 45x minus 45x will give you 0. And then 4 minus negative 135, so minus negative turns into addition. So 4 plus 135 is going to give you 139. So you are done when the remainder spot has no more variables. Since this does not have any more variables, that means we are done, and 139 is our remainder. So our quotient is going to be 4x squared plus 15x plus 45. Then we're going to add to it the remainder, 139, divided by the divisor, x minus 3. And then this is going to be our final answer. So for this next one, before you get started, you might notice, take a look at the two polynomials. The first polynomial is 6x plus 26 plus 2x cubed. So there's all kinds of things wrong with this. First of all, it's not in standard form at all. The powers are not listed from highest to lowest at all, and the constant's not last. And you also might notice that there's an x to the power 3, an x to the power 1, and a constant. What power of x appears to be missing? It appears that we are missing an x to the power 2. So we're going to do a couple of different things with this. We're going to not only put this in standard form, but we are also going to put an x to the power 2. We're going to put a placeholder of 0 in for the missing x to the power 2. Now, since the powers should decrease, the missing 0x squared should go between the x cubed term and the x term. So I'm going to list the 2x cubed first. Then I'm going to put the plus 0x squared next. Then I'm going to put the plus 6x after that, and then the plus 26 is going to go on the end. Then we are dividing it by 2 plus x, which is also not in standard form. So you could easily switch the order of addition, so I'm just going to write 2 plus x as x plus 2. So now that both polynomials are in standard form, and now that I put the 0 in as a placeholder where it should go, I've done a lot of the hard part for you, so I want you guys to try this one and divide these two polynomials. So go ahead and pause the video and then resume when you are done working. All right, so we're going to compare the first term in the dividend, 2x cubed, by the first term in the divisor, 1x to the power 1. And we're going to ask ourselves, what do we need to multiply x by to turn it into 2x cubed? Well, what do you need to multiply 1 by to turn it into 2? You need to multiply it by 2. Then I have an x to the power 1 here and an x to the power of 3 here. How many more powers of x do I need? I need 2 more powers of x, so I'm going to be multiplying it by 2x squared. So then, at the multiplication step, don't forget to put parentheses around the divisor, and don't forget to distribute. So 2x squared times x will give us 2x cubed. Then 2x squared times 2 will give us positive 4x squared. Put parentheses around both of them, and both of them are going to get subtracted. So this is where you absolutely needed that 0x squared as a placeholder. So also don't forget that the minus sign is going to go to both terms. So 2x cubed minus 2x cubed is going to give you 0. Then 0x squared minus 4x squared is going to give you negative 4x squared. Immediately after subtracting, you are going to bring down the next term. So I'm going to bring down the plus 6x. Then I'm going to compare this first term here, this negative 4x squared, to this first term up here, x. And I'm going to ask myself, what do I need to multiply x by to turn it into negative 4x squared? So to turn 1 into negative 4, I need to multiply it by negative 4. I have an x to the power 1 here and an x to the power 2 here. So how many more powers of x do I need? I need 1 more power of x. So then I'm going to take negative 4x and I'm going to multiply it by the divisor and I'm going to distribute. So negative 4x times x is going to give us negative 4x squared. Then negative 4x times positive 2 is going to give us negative 8x. So then you're going to put parentheses around each of these and you are going to subtract both of them. So negative 4x squared minus negative 4x squared is going to give you 0. Then 6x minus negative 8x. Well, minus negative 8x is going to turn into plus. So then 6x plus 8x is going to give you 14x. Then immediately after subtracting, you're going to bring down the next term and take the plus sign with it. So I'm going to immediately bring down the plus 26. So then I'm going to compare this first term down here, this 14x, by the first term of the divisor x. So what do I need to multiply x by to turn it into 14x? Well, I need to multiply it by positive 14 to start. And since my powers of x do match, I don't need any more powers of x, so I'm just going to be multiplying it by 14. So when I multiply, I'm going to remember to distribute. So I'm going to take 14 times x, which is 14x. And then 14 times 2 will give us positive 28. So then put parentheses around both of these and subtract both terms. So 14x minus 14x will give you 0. And then 26 minus 28 will give you negative 2. And since in the remainder spot there are no more variables, that means that we are done. So our quotient is 2x squared minus 4x plus 14. Then adding a negative 2 is the same as subtracting 2 over the divisor x plus 2. And then that is going to be our final answer written as a mixed number. So then for this next one, we are taking the polynomial x squared minus 1 and we are dividing it by the polynomial x plus 1. So first of all, if you take a look at the polynomial on the top, we jump from x squared to a constant, so it does appear that we are missing an x to the power 1. So when I set up my division box, I need to make sure that I put a 0x in the appropriate spot as a placeholder. The x term should go between the x squared term and the constant term. So the polynomial that goes inside the division box is going to be x squared plus 0x minus 1. Then the divisor is going to be x plus 1, and that will go outside the division box. So then I'm going to compare the first term in the dividend, x squared, to the first term in the divisor, x. And I'm going to ask myself, what do I need to multiply x by to turn it into x squared? Well, I just need to multiply it by a 1x. So then at the multiplication step, don't forget to distribute. So x times x will give us x squared, and then x times 1 will give us plus 1x. Put parentheses around both of these, and you're going to subtract both of these. So x squared minus x squared will give you 0. And then 0x minus 1x will give you negative 1x. Immediately after subtracting, you're going to bring down the next term and take the minus sign with it. So then you're going to compare the first term down here, this negative 1x, to this first term in the divisor x. And you're going to ask yourself, what do I need to multiply x by to turn it into negative 1x? Well, I need to multiply it by negative 1. And I don't need any more powers of x. So then I am going to multiply and I'm going to distribute. So negative 1 times x is negative 1x. And then negative 1 times positive 1 is negative 1. Then I'm going to put parentheses around each of these, and I'm going to subtract each of these. So negative 1 minus negative 1 will give us 0. And then negative 1 minus negative 1. Remember, minus negative will turn into addition. Negative 1 plus 1 gives you 0. So it is entirely possible to do some of these polynomial long divisions and get a remainder of 0. We just haven't seen any of them yet. So yes, this will happen. Your remainder is 0. Well, we sort of saw one a few examples ago, but we haven't seen one in a while. So this x minus 1 is your quotient, and since the remainder is 0, you do not even need to indicate a remainder. And if there is no remainder, you don't need to write your answer as a mixed number because it's just adding 0. So what this means is that x plus 1 actually goes into x squared minus 1, exactly x minus 1 times. So this means that x plus 1 is a factor of x squared minus 1. The next chapter is going to be all about factoring. It is going to be all about writing polynomials such as x squared minus 1 as the product of two other polynomials, x minus 1 times x plus 1. So we're going to be seeing factors a whole lot more. A factor happens when you do your polynomial long division and you get a 0 for a remainder. That means that what you divided by, x plus 1, actually goes into x squared minus 1. So just keep that in mind whenever you get a 0 for a remainder. That means x plus 1 actually goes into x squared minus 1. But that factoring business is a whole other chapter, and that is going to be it for polynomial long division, and that is going to be it for your first exam. So thank you all very much for watching. If you have any questions on this or any other videos, as always, you can feel free to email me or send me a message in Canvas, especially if you have any questions about the first exam. So thank you all very much for watching, and I will see you in the next video when we start factoring. So bye-bye.